for example, degradation in the environment, there is a reaction that it takes quite a long time. This is what we all know. So this worm can do that within a few hours from exposure.
Some plastics, like PET, which is used to make plastic bottles like the one I threw away earlier, are easy to recycle. But others, like polyolefins, which can be found in countless things like straws, food packaging, and even carpets, are much harder to degrade. And plastics don't ever fully decompose. They just get broken down into smaller and smaller particles by natural processes. This happens because of oxidation, the chemical reaction that takes place when a substance comes into contact with oxygen in the presence of heat or light. The reaction breaks down the chemical bonds in the hydrocarbon chains through a process called chain scission, resulting in the formation of smaller chain fragments. In nature, this can take anything from 20 to 500 years. But scientists have found that enzymes in the waxworm's saliva can speed up the oxidation of polyethylene to a matter of hours.
When they make their own cocoon, the fresh one attached to plastics, when they do it sometimes attached to a plastic bag, the plastic bag gets broken and debris forms. So we said, okay, there's something coming out of the mouth, and maybe it's attached to the cocoon or not. So we decided to investigate that and collecting the saliva. And saliva in the strict sense is the juice produced by the salivary glands.
So the magic ingredient is the saliva?
So we found out the saliva, in fact, is the magic ingredient. So from the mouth, we recovered the saliva, applied on plastic, on polyethylene, and we found out oxidation again. So we know that this enzyme is capable of oxidizing polyethylene, but there are a lot. If you take a sample of the saliva, there are so many, it's just very condensed. So maybe this, as a first difference compared to other lepidopters that we tried, is the first step. So there are a lot of these proteins. While if you observe saliva from other lepidopters, we don't see that.
Enzymes are proteins that speed up chemical reactions. In fact, almost all metabolic processes in cells need enzymes to make them happen fast enough to sustain life. So how do you get the saliva out of these worms?
Well, with the mouth pipette and the capillary, and it's relatively easy because it we just put the needle in the mouth, but without digging, just the saliva comes out, which is a relatively white liquid. And then we applied lab techniques to analyze the saliva, what kind of proteins are there.
And how do you scale this up? Because presumably you're only getting a tiny bit of saliva.
Well, the idea is to produce the enzymes, the proteins, in a laboratory. Now there are techniques to reproduce in large scale, and that's what we are supposed to do now. Production of enzymes in large scale, and then try to increase the efficiency, stability, all these details which are connected to the study of a protein. We need to produce enzymes in a certain amount to be able to see how much we will need to degrade a certain amount of plastics, because this is key for being able to apply this.
Polyethylene is a very specific plastic, isn't it? How much of our plastic trash does that make up?
It's about 30%, which is a lot. This is one of the polyolefins, one of the most used, and in fact the most produced. And then we have polystyrene, we have polypropylene. These are all polyolefins that together we're talking about between 50 and 70% of global plastic production. So these worms, it has been shown by other labs that they can degrade polystyrene. Polystyrene, polyethylene. Now we are checking polypropylene. Let's see if it works. And then the idea, because the target clearly will be not only the polyethylene, but the mixed plastic. This is the most difficult thing.
Dr. Wei-Min Wu is a former senior research engineer at Stanford University. Together with his colleagues at Beihang University, China, he's also been working on plastic pollution and biodegradation for years. His most recent research focuses on yellow mealworms, the larvae of the darkling beetle.
We studied at least 5 different worms. They belong to so-called a family of darkling beetle. The darkling beetle contains 2,000 members, but right now we only study few of them. We found the yellow mealworm. is the best one. Also other worm, like silverworm, dark mealworm, they also degrade plastic. But mealworm is very popular.
And how do they actually break down the polystyrene?
First, the worm, they chew and they eat the plastic. And then they bite it and then make the plastic particle become smaller. And then this smaller particle get into their gut. And then they squeeze the digestive fruits. It contain, for example, many enzymes and also some emulsified chemicals, organic chemicals. They digest food. And in their gut, they contain a lot of gut bacteria and other microorganisms. These microorganisms and their digestive fluids work together and digest the plastic.
Can mealworms survive on a diet of styrofoam?
They can survive for at least 4 weeks, sometimes 6 weeks, even longer. Because they can digest the plastic, they generate energy, from the digestion and get a carbon source. Unfortunately, this plastic don't provide the nutrients, especially mineral nutrients. So they could not support mealworm growth. Just like a human being, we only eat rice, and then we can survive, but we get sick.
And how fast can they break down the plastic? How long does it take?
Oh, it's very fast. They eat the plastic get into their digestive system. It take about 12 to, I think, 15 hours, and then discharges thickener or poo-poo, mealworm poo-poo. And during this period, at least 50% plastic are digested.
What are your hopes for the future of this research?
Oh, the future research, I think this is a wonderful discovery. This gave us some idea. There could be some way, to solve the plastic pollution issues. It could, eventually we understand, what happened, how this system works. We could develop biotechnology for, plastic degradation and recover, valuable chemicals from the waste plastic.
Plastics are designed to be nearly indestructible. Only 9% is currently recycled. 60% of plastic waste is incinerated or goes into landfill, and a further 30% leaks out into our environment, where it will pollute natural ecosystems for hundreds of years.
If we think about the plastic waste management, to date, we don't have many solutions. And we have recycling, we have incineration, and then landfill sites accumulation, and then so leak into the environment. And biotechnology could be one of the solutions for plastic waste management. There are no technologies so far because they have not been developed yet, but this could be one of these. It could be the first, actually. And so if we manage to arrive at the point in which you can apply liters of this solution of enzymes to piles of plastic, maybe there will be the way to tackle this problem.
You can see more of Razor on our YouTube channel. Search for Razor Science Show and it will take you straight there. Remember to subscribe and hit the bell button for notifications.
There's a new agenda for a new world, accelerating change in almost every part of our lives. It's shifting the norms of how we work, travel, and connect. How we think, interact and develop. It's a new reality, a new agenda with me, Juliette Mann.
Here we go then, this is what we've all come to Silverstone for. The British Grand Prix, and it's lights out and away we go.
In Formula One, it can go wrong fast.
There's the initial content. That's where the car then is upside down.
In 2022, Alfa Romeo driver Zhou Guanyu, the first Chinese driver in Formula One history, crashed in the opening lap of the British Grand Prix.
The car digs in and you do not ever want to see...
Years ago, this was the
like
kind
that.
of crash that would have resulted in certain death.
Race control, so Joe is okay.
The roll hoop above his head was crushed and he was left trapped in the wreckage. Later, when the shock had worn off, Joe realised he was lucky to be alive.
Yeah, well, I was always so quick. I was just waiting for the last hit because that's the hit will damage me or not. So. Yeah, I knew I was okay after I hit. I was confident, you know, I know what's going on. I feel a little bit my legs. So.
His life was saved by a protection device introduced in 2018 called the Halo that was tested here at the Cranfield Impact Centre. It's located at Cranfield University, known for motorsport-related research and development, as well as its close working relationship with world-class racing teams. Jim Watson is the manager. You are one of only, what, 2 FIA-approved impact or crash test centres for the Formula One teams?
That's right, yes, because back in the late 80s, when we first started, we did the first crash test here. And then ever since then, we've been supporting the F1 industry, all the teams, UK-based teams, performing those crash tests.
The centre has undertaken consultancy, research and testing for the motorsport industry since the 1970s. 50% of the F1 teams run their impact testing here to increase the chances of survival when it all goes wrong on the